So we're just going to solve a few equations here, basic equations, and but we're going to be using trig functions and their inverses. So for example, if I've got 7 times the sine of x minus 4, so 7 times the sine of x minus 4. First of all, you should recognize that if we're going to be doing inverse functions, we've got to restrict our domain. So my domain right now is going to be from negative pi over 2 to pi over 2. And one of the ways I know that is because there's nothing, I haven't shifted anything, so there's no addition or subtraction in here. Now my range is going to be different because I've got an amplitude and I've dropped it 4. So I'm going to use this pretty picture because I already drew it. Okay, so instead of going up to 1 and down to negative 1, I'm actually going to go up to 7 and down to negative 7, but then I'm going to drop this thing by 4 units. So I need to drop the 7 by 4, which means I'm going to peak out at 3. And I need to drop the negative 7 by 4, which means my value will be at negative 11. So my range on this is going to be from negative 11 to positive 3. From negative 11 to positive 3. Well, now what I want to do is solve. So the first thing I want to do is flip-flop my x's and y's, and then I will solve for y. So what I have right now is x equals 7 times the sine of y minus 4. So I flip-flop my x's and y's, and now I need to solve for y. So I need to start chipping stuff away until I can get to the trig function, and then I'll use inverse trig functions to get this y out. So I'm going to add 4 to both sides. So x plus 4 equals 7 times the sine of y, and then I'm going to divide both sides by 7. So I get the sine of y equals x plus 4 over 7. So I'm going to rewrite him so you can see what's happening. So the sine of y equals, not an s, no, x plus 4 over 7. But I need to release this y from captivity. So what I learned a while ago is trig functions and their inverses undo each other. So since I've already restricted my domain, I don't have to worry about doing this. Okay, so I'm going to take the arc sine of both sides. So I'm going to take the arc sine of both sides, which means these two things undo each other, and then what pops out is y. So y equals the arc sine of x plus 4 over 7. Then it's going to ask you for the domain. Well, your domain on the original is your range on the inverse. Your range on the original is your domain on the inverse. So your domain will be from negative 11 to 3, and your range will be between negative pi over 2 to positive pi over 2. So let's do another one. What happens if I've got negative 3 times the cosine of 7x? Negative 3 times the cosine of 7x. And remember, this is a compression. This is a horizontal compression. It's going to affect the period of your function. So my domain is actually given to me as 0 is between x, which is 0 is between x. X is between 0 and pi over 7. And that's given to you. So that's your domain. Well, what's your range going to be? So your range, it did not shift up or down. It did flip, but I don't care about that. And your amplitude is now 3. So instead of going from negative 1 to positive 1, it's going to go from negative 3 to positive 3. Okay, so x will be between, y will be between negative 3 and positive 3. So now I can focus on solving the equation. When I said y will be between, it's because I'm dealing with my range. Okay, but when you flip-flop this will become what your y values are, and this will become what your x values are. Okay, I had to make that clear. Now I'm going to flip-flop my x's and y's. So I get negative 3 cosine of 7y. And now I'm going to solve for y, which means I need to get rid of this negative 3. So I'm going to divide both sides by negative 3. So I get negative x over 3 equals the cosine of 7y. So I've almost got this thing done, but I still have to get rid of this cosine so I can get to the y. So the way I'm going to do that is take the arc cosine of both sides. Notice I didn't flip-flop my equation like I did on the last one. On the last one, I had the sine of y on the right, and then I just wrote it backwards. I don't care when you do that. I'm fixing to do it now. So this undoes itself. So I end up with 7y equals the arc cosine of negative x over 3, and then I need to divide both sides by 1/7, or by 7, which will give me a 1/7. So I've got 1/7 of the arc cosine of negative x over 3. So that's how we solve that one. And let's do one more. And then the word problems on this one, actually let's do two more. The word problems on this one are pretty much just calculator problems. You just slap them in your calculator and make sure you know how to do that. So, here we go. I have y equals the negative tangent of x plus 3 minus 1. And then, sorry, let me silence my phone, shall I? Hang on one second. So I have that, and I need to go ahead and restrict my domain. So my domain, now look at what you've done, is you've made a phase shift of to the left 3. So my original domain would have been a negative pi over 2 to a positive pi over 2, but I shift it to the left 3. So your domain is going to be take this negative pi over 2 and go left 3 is less than or equal to x is less than or equal to pi over 2, but shift that to the left 3. So that's what that mess means in your homework when you're looking at it, is you just took the negative pi over 2 to the positive pi over 2, but you shifted them both to the left 3 units. So now I've got x equals negative tangent of y plus 3 minus 1. So I'm going to add 1 to both sides. Oops, sorry, what's your range? Your range, well, what's your range on tangent? Your range is from negative infinity to positive infinity. Okay, so now you know what your range is and what your domain is on your inverse function. So now we can go in and start solving. So I'm going to add 1 to both sides. So I've got x plus 1 equals negative tangent of y plus 3. And that's almost alone. I need to kill this negative. So I've got this term, and this term, and I'm just going to multiply through by negative 1. So I get negative x minus 1 equals a positive tangent of y plus 3. And now I'm going to take the arctangent of both sides. So arctan of this and arctan, only because I'm running out of room, of that will give me a y plus 3 equals the arctangent of negative x minus 1. And then I just need to subtract 3 from both sides. So minus 3 is going to be the equation of your inverse. So let's do one more. And what we have is 6 times the arc cosine of x minus 3 pi is going to equal 3 times the arc cosine of x. And I want to solve this thing. Okay, so here I go. So I've got this chunk minus this chunk equals that chunk. And I notice I got some like terms that contain my x's. So I'm going to subtract 3 arc cosines of x from both sides. And that's going to leave me with 3 arc cosines of x minus 3 pi now equals 0. Okay, that now equals 0. So now what do I want to do? I want to start getting this thing by itself again. And then how am I going to get that x out? I'm going to do the inverse trig function. So what's the inverse of arc cosine? It's cosine. So I'm going to add 3 pi to both sides. I'm going to divide both sides by 3. And now I'm going to take the cosine of both sides. So the cosine of the arc, or of the arc cosine of x will be x, and that's going to equal the cosine of pi. Well, do I know what the cosine of pi is? I do. it's negative 1. So x equals negative 1. All right, so we've got that one. All of those are trig functions. So what I'm going to do at this point is I am going to build triangles. And this is where we're going to be headed in the next one. So in the next section. But what I have is the cosine of the arc sine of x. And that needs to equal the tangent of the arc cosine of 12/13. Okay, and that thing looks like an absolute mess. Okay, so what I'm trying to find is I need to find out what the cosine is here. Okay, and it may be kind of messy when we do this thing, but this is, again, this is taking us to where, this is taking it, that's a 13. Holy cow, that'd have been bad. Okay, this is taking us to a place where we're going to be able to solve this equation. So first of all, remember that the arc trig function of a ratio. So this is a ratio. The arc cosine of a ratio. So this is a ratio. Okay, and what I can do is I can change these things, kind of manipulate them around. So this is actually a triangle. I can build this. I know two sides of a triangle. So that side, I know that sine, and this is going to be handy in the next section, sine is opposite over hypotenuse. So this is x over 1. And now I can use Pythagorean Theorem to solve the rest of it. So I get, and I know that you're like, but wait, that's y. I'm going to write this in terms of x as well. Okay, so let's just say that this is y for right now so that we can find out what y is. So I've got x squared plus y squared is 1. I want to know what this portion is, so I'm going to solve for y. So I'm going to subtract x squared from both sides, and then I'm going to take a root. Okay, so I now know that this side is 1 minus x squared. Okay, so here's what I've got. I've done the inside part. I've created a triangle that contains the angle that makes this ratio true. So the cosine of that angle is going to be adjacent over hypotenuse. So I'm going to write that on a separate paper. I've got adjacent over hypotenuse. So the cosine, this entire side right here, is going to become adjacent over hypotenuse, which is the square root of 1 minus x squared. So my left side turned into that. Okay, my left side turned into that because it's the square root of 1 minus x squared over 1. Well, I'm not going to write the over 1. So now let's do the right side. I've got the inverse trig function of a ratio, which means I can make a triangle. Okay, so I've got cosine is adjacent over hypotenuse, and now I can use Pythagorean Theorem to find out what this side is. So that's going to be the y that I'm missing. So this is adjacent over hypotenuse, and then Pythagorean Theorem is going to tell me that that's 5. Okay, because 169 minus 144 is 25, square root of 25 is 5. Do I know what the tangent of that is? Tangent is opposite over adjacent. So this entire right side of the equation just turned into 5/12. So come on back over here. The right side is now 5/12 because I found the tangent of that angle. So now I just need to solve for x. So I'm going to square both sides. And that's going to be 1 minus x squared is going to be 25 over 144. Okay, I need to subtract 1 from both sides. So I get a negative x squared equals 25 minus 144. It's going to be small. So 25 minus 144 is going to be negative 119 over 144. Okay, so I just did, in my calculator, 25 over 144 minus 1, math, enter, enter, is negative 119 over 44. Okay, but I don't care what this is. So I need to, what did she just say? I don't care what x squared is, I care what x is. I also need to notice that both sides are negatives, so I'm going to change them both. I'm going to divide by negative 1. And now x is, take a square root of both sides. X is either going to be root 119 over 12 or negative root 119 over 12. So that is section 8.1. And then 8.2 we've already laid the foundation for, so we're just going to dive in and do examples with those.